Welcome to our new video. Today's video is full of exciting events and important historical moments. But before we start, hit the like button, subscribe, and support us so we can keep going, and let's begin. In the annals of Western thought, few figures are as enigmatic and influential as Pythagoras of Samos. Remembered colloquially for a geometric theorem, the man himself was far more than a mathematician. He was a philosopher, a spiritual guide, and the charismatic founder of a secret society that sought to unravel the very fabric of the cosmos. To understand the mysterious brotherhood he created, one must first understand the seeming, mythical man who stood at its center, a figure who straddled the worlds of rational inquiry and divine revelation. Pythagoras was born around 570 BCE on the Greek island of Samos, off the coast of modern Turkey. Historical details of his early life are sparse, drawn from accounts written centuries after his death, which often blur the line between biography and hagiography. Nevertheless, a consistent tradition holds that Pythagoras was a relentless seeker of knowledge. As a young man, he is said to have visited the preeminent thinkers of his time on the nearby island of Miletus, the philosophers Thales and Anaximander, who were pioneering a new, rational approach to understanding the natural world. However, his quest for wisdom reportedly led him far beyond the shores of Ionia. Ancient sources claim he embarked on extensive travels to Egypt and Babylon, immersing himself in the ancient lore of these civilizations. It is believed that in Egypt, he studied with priests in Thebes, where he was supposedly granted the rare privilege of participating in their worship and was initiated into their geometric and mathematical secrets. From these Eastern traditions, he is thought to have absorbed foundational concepts that would become central to his own philosophy: the belief in metempsychosis, the transmigration and reincarnation of the soul, and the use of mathematics as a sacred key to cosmic order. While the historicity of these specific journeys is debated by modern scholars, their narrative importance is undeniable. The power of the Pythagorean system did not lie in a single original invention, but in a radical synthesis. Pythagoras masterfully fused the nascent rationalism of Ionian Greek philosophy with the ancient mystical traditions of the East. This created a comprehensive way of life that was unique in the ancient world, offering its adherents a path to spiritual salvation that was paved with the stones of scientific and mathematical inquiry. It was a system where the purification of the soul was not just a matter of ritual, but of intellectual enlightenment. This potent combination of science and religion, of logic and mysticism, formed the bedrock of the society he would go on to build. Around the age of 40, in approximately 530 BCE, Pythagoras emigrated from his native Samos to the city of Croton, a thriving Greek colony in southern Italy. His reasons for leaving were likely political. Samos had fallen under the control of the tyrant Polycrates, and Pythagoras may have been seeking a place where his intellectual and political ambitions could flourish unhindered. The choice of Croton was opportune. Some historical accounts suggest that upon his arrival, the city was in a state of crisis, perhaps suffering from moral decay or reeling from a significant military defeat against its rival Locri. In this climate of uncertainty, the people of Croton were receptive to a new voice. Pythagoras, a charismatic and skilled orator, arrived not merely as a teacher but as a moral reformer. He addressed the city's elders, its young men, and its women, advocating for moderation, piety, and respect for the state, and he quickly garnered a devoted following. It was here in Croton that Pythagoras established what ancient sources call his school. This term, however, is misleading. The institution he founded bore little resemblance to a modern academy. It was far more akin to a secret society or a monastic order. Adherents were bound by a strict vow of loyalty to Pythagoras and to one another. Their purpose was twofold: to pursue a life of religious and ascetic observance, and to study the master's profound philosophical and mathematical theories. This brotherhood would soon grow in influence, becoming a dominant force in the political and cultural life of Croton and its surrounding cities. The authority of Pythagoras within his society was absolute, cemented not only by his intellectual brilliance but also by a carefully cultivated aura of divinity. His followers, particularly in later accounts, did not view him as a mere mortal but as a semi-divine figure, a prophet sent by the gods to guide humanity. A collection of extraordinary legends surrounded him, serving to elevate his status and render his teachings unquestionable. It was claimed that Pythagoras possessed a thigh made of pure gold, a physical mark of his otherworldly nature. Stories circulated of his miraculous abilities. He could be seen in 2 different cities at the exact same time. He could predict the future, and he had even traveled to the underworld and returned with knowledge of the dead. In one famous tale, as he crossed the river Causes, the river itself was said to have spoken his name aloud in greeting. These supernatural tales were more than just folklore. They were a functional mechanism of ideological control. In an era largely reliant on oral tradition, a leader's pronouncements needed a source of unimpeachable authority. By framing Pythagoras as a divine being, his teachings were transformed from philosophical arguments into sacred dogma. Disagreement was not an intellectual exercise but an act of impiety. This led to the famous maxim within the school. Eps dixit, he himself said it, a phrase used to end any debate, implying that the master's word was the final, unassailable truth. The mythology surrounding Pythagoras was, therefore, essential for maintaining the cohesion of the brotherhood and enforcing the rigorous and often bizarre rules of the Pythagorean way of life. It established a cult of personality so powerful that it could command the absolute obedience required for his grand experiment in living. The Pythagorean brotherhood was defined by its intense secrecy and its highly structured way of life, sebios, which set its members apart from the rest of society. It was an all-encompassing system of ethical conduct, ritual observance, and intellectual discipline, designed to purify the soul and align it with the harmony of the cosmos. To join this inner circle was to submit to a radical transformation of one's entire existence. Admission into the Pythagorean school was not open to all. It was a closed, meritocratic society where prospective members were carefully selected based on their discipline and character. Once chosen, an initiate began a demanding probationary period. The most famous feature of this initiation was a mandatory 5-year vow of silence. During this time, the novices were known as the kosmatikoi, or listeners. They were permitted to attend the master's lectures, often delivered from behind a veil or screen, but they were forbidden from speaking or asking questions. Their role was simply to listen, absorb, and obey, internalizing the foundational precepts of the philosophy. This period of silence served as a test of fortitude and humility, filtering out those who lacked the necessary self-control. Those who successfully completed this trial could advance to become members of the inner circle, the mathematikoi, or learners. These were the true initiates who were permitted to see Pythagoras face to face and engage directly in the deeper mathematical, musical, and cosmological studies that formed the core of the society's wisdom. Life within the brotherhood was communal and ascetic. Upon joining, members were required to surrender their private property, which was then held in common by the sect. This practice was rooted in the maxim koin de ti phon, all things in common among friends. The Pythagoreans were devoted to one another to the exclusion of outsiders, forming a tight-knit community that provided mutual support and enforced collective discipline. Daily life for a Pythagorean was governed by a set of oral teachings known as the akosmata, things heard, or symbola, as tokens, or passwords. These were cryptic sayings that prescribed a strict code of conduct and a host of ritual prohibitions. The goal was to make philosophy a lived, embodied experience, transforming every mundane action into an act of ritual purity and mindfulness. The daily routine was highly structured. It began with solitary walks at dawn to contemplate the natural order, followed by physical exercise, athletics, or therapeutic dancing to purify the body. Breakfast was simple, often consisting of bread and honey. The day was dedicated to study and work, followed by another walk in the late afternoon, this time in small groups to discuss the day's learning. The day concluded with communal meals, eaten in silence or with solemn readings, and a final period of contemplation before sleep. Central to their ethical practice was a strict vegetarian diet. This was not based on health concerns, but was a direct consequence of their belief in metempsychosis, since any animal could potentially house the soul of a reincarnated human, perhaps even a friend or ancestor. The act of slaughtering and eating an animal was considered a form of cannibalism and a grave transgression against the cosmic order. To inflict pain on any living creature was to diminish one's own moral virtue and disrupt the soul's journey toward purification. Beyond this, the akosmata included a series of enigmatic prohibitions that struck outsiders as bizarre. Members were forbidden from eating fava beans, a staple of the Greek diet. The reasons given in ancient sources are varied and strange. Some claimed beans contained the souls of the dead, while others suggested they caused flatulence, which disturbed the harmony of the body and soul by taking away the breath of life. Other rules included: do not stir a fire with a knife, do not step over a yoke, when you take off your shoes, do not leave the right one before the left, and when you have risen from the bedclothes, roll them together and efface the impress of the body. While these rules may seem arbitrary, they functioned as a system of behavioral conditioning. A rule like "do not stir the fire with a knife" could be interpreted symbolically as a command not to provoke an angry person with sharp words. Effacing the impression in one's bedclothes could be a reminder to leave no lingering resentment from the previous day. Regardless of their specific meaning, these constant, daily rituals served to create a powerful group identity, setting the Pythagoreans apart from the world and reinforcing the idea that every action, no matter how small, had philosophical and cosmic significance. At the heart of the Pythagorean brotherhood lay a revolutionary and all-encompassing philosophical system. It was a vision of the universe as a perfectly ordered, harmonious entity, a cosmos, whose secrets could be understood not through mythology or mere observation, but through the divine language of number. This intellectual framework was not just a subject of study, it was the very lens through which the Pythagoreans perceived all of reality. The foundational doctrine of Pythagoreanism, the principle from which all else flowed, was the declaration that all is number. This was a radical metaphysical claim. For the Pythagoreans, the universe was not merely describable by mathematics, it was fundamentally composed of numbers. Numbers were not abstract human inventions, but the divine, tangible essences of all things. Reality itself depended on an invisible world of number, which could only be grasped by pure reason. They explored this concept through a unique visual approach to arithmetic. Unlike their contemporaries who used letters for numerals, the Pythagoreans represented numbers with arrangements of pebbles or dots, zabrosifit. This practice allowed them to discover the deep connections between arithmetic and geometry. They identified triangular numbers, Seb 1, 3, 6, 10, square numbers, Seb 1, 4, 9, 16, and oblong numbers, visualizing numerical relationships in spatial terms. This numerical essentialism extended to every facet of existence, including abstract moral and social concepts. They believed that even intangible qualities had their own number. Justice, for instance, was associated with the number 4 because it is the first square number. 2 multiplied by 2 equals 4, representing a perfect and equal balance. Marriage was the number 5, seen as the harmonious union of the first female numbers 2, considered even and unlimited, and the first male numbers 3, considered odd and limited. 10. The sum of the first 4 integers 1 plus 2 plus 3 plus 4 equals 10, was revered as the decad, the perfect number that contained the whole of nature and formed the basis of the cosmos. This worldview was built upon a fundamental duality, a system of cosmic opposites that governed all phenomena. This was famously codified in the Table of 10 Opposites, recorded by Aristotle, which provided a framework for their entire cosmology. The Pythagorean Table of 10 Opposites: first pair limit unlimited, second pair odd even, third pair one many, fourth pair right left, fifth pair male female, sixth pair rest motion, seventh pair straight curved, eighth pair light darkness, ninth pair good evil, 10th pair square oblong. This table demonstrates the breathtaking scope of their system. The primary opposition, limit versus unlimited, was represented mathematically by odd versus even numbers. This fundamental pair was seen as the active principle that brought orders, cosmos, and harmony to the universe, with all other opposites flowing from it. For the Pythagoreans, mathematics was the key that unlocked the ethical, physical, and metaphysical structure of reality itself. The most sublime expression of the all is number doctrine was the concept of musica universalis, the music of the spheres. This idea was born from a discovery that was, for the ancient world, a profound revelation: the link between musical harmony and numerical ratio. The discovery is apocryphally attributed to Pythagoras himself, who, according to legend, was passing a blacksmith's shop and noticed that the sounds of the hammers striking the anvil produced harmonious intervals. Upon investigation, he found that the hammers whose sounds were consonant had weights that stood in simple, whole number ratios to one another. This principle was more systematically demonstrated with a monochord, a single stringed instrument. The Pythagoreans discovered that plucking a string produces a certain note. Plucking a string of half the length produces a note an octave higher. A ratio of 2:1. A ratio of 3:2 produces a perfect fifth, and a ratio of 4:3 produces a perfect fourth, the most pleasing and fundamental intervals in music. This was a world-changing insight. It proved that an invisible, aesthetic quality like musical consonance was governed by the pure, rational logic of number. If music was number made audible, they reasoned, then perhaps the entire cosmos was a form of silent music. They extrapolated this principle to the heavens, proposing a revolutionary cosmological model. In their system, the Earth was not the center of the universe. Instead, the Earth, Sun, Moon, and the 5 known planets all orbited a central fire, which they called the heart of the universe, to account for the perfect number 10. They even posited the existence of a counter Earth, perpetually hidden from view on the other side of the central fire. Crucially, they believed that the distances of these celestial bodies from the central fire, and thus their orbital speeds, corresponded to the same mathematical ratios that governed musical harmony. As these massive bodies moved through the heavens, they must produce a sound, and because their movements were ordered by perfect numerical proportions, the resulting sound must be a continuous, magnificent celestial harmony, the music of the spheres. When asked why humans could not hear this cosmic symphony, they offered a clever explanation: the sound is in our ears from the very moment of birth. Since we have never experienced true silence to contrast it with, we cannot distinguish it. For the Pythagoreans, the universe was a grand musical instrument, and to study astronomy and mathematics was to learn to hear its divine music with the soul, if not with the ear. The entirety of the Pythagorean cosmic doctrine, its numerology, geometry, music, and cosmology, was encapsulated in a single sacred symbol, the tetractys. This figure, a triangle composed of 10 dots arranged in 4 rows, was the most important mystical symbol of the brotherhood. It was an object of deep meditation and such profound reverence that initiates swore their most solemn oaths by it. The tetractys was a visual representation of the principle that all is number, and a complete model of the universe in miniature. Its meaning was multi-layered, revealing the interconnectedness of all aspects of their philosophy. Numerical and arithmetical significance: the tetractys is formed by the first 4 positive integers 1, 2, 3, and 4. The total number of dots is 10. 1 plus 2 plus 3 plus 4 equals 10. This number, the decad, was considered perfect because it contained the first 4 numbers and represented a unity of a higher order, the foundation of all numbers and, by extension, all things. Geometrical significance: the symbol was a map of the generation of spatial dimensions from the dimensionless point. The top dot, the monad, represented a point, having 0 dimensions. The second row of 2 dots defined a line, representing 1 dimension. The third row of 3 dots, which forms a triangle, defined a plane representing 2 dimensions. Finally, the fourth row of 4 dots allowed for the construction of a tetrahedron, the simplest 3-dimensional solid. Thus, the tetractys showed how the entire physical world emerged from the primordial unity. Musical significance: the tetractys contained the secret to musical harmony. The ratios formed by the numbers in its rows, 2 to 1s, the second row to the first, 3 to 2, the third row to the second, and 4 to 3, the fourth row to the third, correspond precisely to the fundamental consonant intervals of the octave, the perfect fifth and the perfect fourth. The symbol was therefore a blueprint for the Pythagorean musical scale and the harmony that structured the cosmos. Cosmological significance: the 4 rows of the tetractys were also seen as symbolizing the 4 classical elements of fire, air, water, and earth, the 4 seasons, and the fundamental structure of the cosmos itself. It was a metaphysical seed that contained in symbolic form all the principles of the natural world and the ascent to the divine. In a prayer addressed to the symbol, the Pythagoreans hailed it as the root and source of the eternally flowing creation and the key-holder of all. For them, the tetractys was not just a clever diagram, it was the divine blueprint of existence, while the relationship in a right-angled triangle expressed by the equation a squared plus b squared equals c squared was known to earlier civilizations like the Babylonians for practical purposes. It was the Pythagoreans who are credited with its first formal proof and, more importantly, with elevating it to a principle of profound philosophical significance. For the brotherhood, the theorem that bears their name was not merely a useful tool for construction or measurement, it was a sublime confirmation of their entire worldview. The theorem was a perfect, concrete demonstration of the doctrine that all is number. It revealed a hidden, eternal, and perfectly harmonious relationship governing geometric space. It showed how the seemingly disparate lengths of the sides of a right triangle were bound together by an elegant numerical law. This was sacred geometry, a glimpse into the rational mind of the divine creator. Its philosophical weight can be understood through the lens of the Pythagorean table of opposites. The two shorter sides, A and B, can be seen as representing the principle of the limit. They are definite finite components. The hypotenuse, C, is the result of their interaction, a synthesis that bridges the space between them. The theorem itself, the equation, is the harmonia, the fitting together, the immutable law that imposes order on this relationship and resolves the tension into a perfect, eternal equality. It was a metaphysical statement about the fundamental structure of reality, proving that the cosmos was not chaotic, but was built on a foundation of rational, harmonious principles. The beauty of the theorem was not just in its utility, but in its revelation of a perfect order hidden within the world of forms. This very perfection, however, held the seed of a crisis that would shake the Pythagorean worldview to its core. The Pythagorean cosmos was a pristine, orderly world built entirely from the elegant ratios of whole numbers. It was a universe of perfect harmony, where every phenomenon, from the notes of a lyre to the orbits of the planets, could be understood through this divine arithmetic. But this perfect world was about to be shattered from within by a discovery so profound and so terrifying that it was deemed an unspeakable heresy, a truth that threatened to unravel the very fabric of their reality. The agent of this crisis was reportedly a Pythagorean named Hippasus of Metapontum. The story, shrouded in legend, holds that Hippasus was contemplating the properties of a simple geometric figure, a square, with sides of length 1. Applying his own master's theorem to find the length of the diagonal, he set up the equation 1 squared plus 1 squared equals c squared. That means c squared equals 2. The length of the diagonal, therefore, was the square root of 2. Hippasus then attempted to do what any Pythagorean would assume was possible: express this length as a ratio of two whole numbers, but he found that he could not. Through a rigorous logical proof, most likely a geometric form of reductio ad absurdum, he demonstrated that the square root of 2 could never be expressed as a fraction. This number was of a new and terrifying kind. It was irrational. The side of a square and its diagonal were uncommensurable. They shared no common unit of measure. For a modern mind, the discovery of irrational numbers is a fascinating mathematical milestone. For the Pythagorean brotherhood, it was a philosophical and religious catastrophe of the highest order. Their entire cosmology, their physics, their ethics, and their spirituality were built on the axiom that all is number, which to them meant that all things could be understood through the ratio of integers. The harmony of music, the order of the heavens, the very nature of justice, all were predicated on this belief. The discovery of an irrational length, a real physical quantity that existed in the world but could not be captured by their system of numbers, was blasphemy. It was as if a gaping void had been torn in the fabric of their orderly universe, revealing a glimpse of an underlying chaos and meaninglessness where they had seen only divine reason. The theorem of Pythagoras, once the ultimate symbol of cosmic harmony, had ironically become the instrument that revealed a fundamental flaw in their understanding of the cosmos. This moment represents a pivotal point in the history of thought, where a purely logical proof collided violently with a dogmatic worldview. The brotherhood was founded on the power of reason, but reason had now produced a result that undermined the system's most sacred foundation. They were faced with an impossible choice: abandon the dogma that gave their lives meaning, or deny the undeniable truth of a logical proof. They chose the dogma. The reaction of the brotherhood to this crisis is the subject of dark and conflicting legends, which, whether literally true or not, illustrate the gravity of Hippasus' transgression. The most famous and dramatic version of the story claims that Hippasus revealed his discovery to members outside the inner circle, breaking the society's strict code of secrecy. For this act of intellectual treason, his fellow Pythagoreans took him on a sea voyage, and horrified by the irrational chaos he had unleashed upon the world, threw him overboard to drown, a punishment for his impiety. Other, less violent accounts suggest that he was simply expelled from the brotherhood, and a symbolic tomb was erected for him, as he was now considered dead to the society. Another version claims his death at sea was a natural accident, but that his brethren saw it as divine retribution from the gods for his discovery, and wished they had been the ones to do the deed. While the exact fate of Hippasus remains a historical mystery, the legends surrounding him are profoundly significant. They mark one of the first recorded instances where a mathematical proof was treated as a moral crime, and its discoverer a heretic. The story of Hippasus is the story of a truth they could not refute intellectually, and so sought to silence physically. It transformed a number into something that could be considered evil, not for its application, but for its very existence, demonstrating the terrifying power of a new idea to threaten a deeply entrenched world order. The intellectual crisis precipitated by the discovery of irrational numbers was a prelude to the physical destruction of the Pythagorean society. While their philosophical system was shaken by an internal contradiction, their worldly existence was threatened by external forces. The very qualities that defined the brotherhood, its secrecy, its elitism, and its growing political power, sowed the seeds of its violent downfall. Yet, in a supreme historical paradox, the fiery end of the Pythagorean communes would ensure the immortal legacy of their ideas. For decades, the Pythagorean brotherhood had grown in power and influence, not just in Croton but across the cities of Magna Graecia. Their members were often drawn from the wealthiest and most prominent aristocratic families, and through their influence on the ruling councils, they guided public policy according to their strict moral and philosophical principles. However, this success bred resentment. Their way of life, so different from that of ordinary citizens, was perceived as arrogant and strange. Their secrecy fueled suspicion, with rumors spreading that they were a political conspiracy aiming to seize total control. Their elitism was a source of constant friction. They publicly shamed and rejected applicants they deemed unworthy, and their loyalty was to the brotherhood above all else, even above family. A Pythagorean would share his goods with a fellow initiate, but not with his own non-Pythagorean relatives, reinforcing the image of an exclusive and aloof clique. This simmering hostility was fanned into flame by political rivals. In Croton, a wealthy and influential nobleman named Cylon, who had been rejected for membership in the brotherhood due to his violent character, became a leader of the anti-Pythagorean faction. He and others capitalized on popular discontent, portraying the Pythagoreans as tyrants in waiting who opposed democratic reforms and hoarded power for themselves. The brotherhood's high-minded purity had made them powerful, but it had also made them dangerously isolated and widely despised. The backlash, when it came, was swift and brutal. Around 510 BCE, following Croton's victory over the rival city of Sybaris, a victory the Pythagoreans had helped orchestrate, the conflict erupted into open violence. Mob, incited by democratic leaders or rival oligarchs, attacked the Pythagoreans. Their meeting houses, the centers of their secret rites and studies, were set ablaze. According to one dramatic account, a large group of Pythagoreans was gathered in the home of the famous athlete and brotherhood member, Milo of Croton, when the building was surrounded and set on fire. Many of the leading members of the society were killed in the inferno and the subsequent purges. A second, more widespread wave of attacks in the mid-5th century BCE effectively destroyed what remained of the Brotherhood's political power across southern Italy. The fate of Pythagoras himself is uncertain. Some traditions hold that he was killed during the first wave of persecution. Others claim he escaped the flames but died shortly thereafter in the city of Metapontum, either from starvation or by suicide out of grief for his murdered followers. The surviving members of the Brotherhood were scattered, forced to flee as political refugees to other parts of the Greek world such as Thebes and Phlius. The great social and political experiment of the Pythagorean way of life had come to a bloody and definitive end. Though the Brotherhood was physically destroyed, its ideas proved to be its immortal soul. The society's spectacular failure as a political entity became the very catalyst for its monumental success as an intellectual movement. Had the Pythagoreans survived as a secretive, isolated cult, their doctrines might have remained esoteric and eventually faded into obscurity like the Mithraic mysteries. Instead, the violent dispersal of its surviving members broadcast their revolutionary ideas across the Hellenic world. Refugees like Philolaus and Archytas carried the Pythagorean doctrines to mainland Greece, where they taught more openly. It was here that their ideas entered the mainstream of Greek philosophy and were encountered by its most brilliant mind, Plato. Plato was profoundly influenced by the Pythagoreans, absorbing their core tenets and weaving them into the fabric of his own philosophical system. The Pythagorean belief in an intelligible reality governed by mathematics, the concept of the immortal soul, and its purification through reason, the dualistic structure of the cosmos, and the search for harmony became foundational pillars of Platonism. Through Plato, the Pythagorean inheritance was transmitted to Aristotle and from there, to the entire subsequent course of Western civilization. The quest to understand the universe through mathematics, a quest begun in a secret society in southern Italy, would inspire thinkers for millennia, from the astronomers Copernicus and Kepler, who consciously revived the idea of a harmonious cosmos, to the physicists Galileo, Newton, and Einstein. The fire that burned the Pythagorean meeting houses was the very fire that illuminated the path for Western science and philosophy. The Brotherhood was dead, but in its demise, its vision of the cosmos had been set free.